Good morning, everyone. Very good morning. Why I'm smiling? Because I think that class is late, but this is for one only. So, good morning, everyone. Good morning. Shall we begin the session? Not now. Why? Today's topic is chapter number 6, memory hierarchy. All right. So, wait for another 5 minutes. Not an issue. So let's begin with the session. Today's topic is chapter number 6, that is a memory hierarchy. How to use a memory hierarchy, or what are the various advantages of using the memory hierarchy, or what are the various benefits that lies between the memory hierarchy, how we can judge with the memory hierarchy, or how we can take out what are the various memory hierarchy terms that is used within the hierarchy. So one is a storage technologies, one is a locality, one is a memory hierarchy, then cache memory, writing the cache friendly code, putting it together, that is what is the impact of the cache on the program performance, then summary. So these are the various topics that is covered in this memory hierarchy. Now let's start with first one, that is a storage locality. So in storage locality means where the data will be stored, that is either in the cache memory, either in the register. So there are multiple stages, multiple memory hierarchy. One is a register. So whatever the data, whatever the scenario that we are using, that is available within the primary memory, cache memory, or any other memory. So that becomes registers, or that becomes we can say the memory hierarchy, right? So that, yes, that is well written program tend to make the storage as frequently as possible to the storage devices. So next part is why we use the memory hierarchy. So because of the memory system, there is a hierarchy of the storage devices that is different from the practices, capacities to cost. As I told you, there are multiple hierarchy of the memory, like registers, primary memory, main memory, right? And the main memory stage is stored on a large disk or the slow disk, which in turn serve as a staging area for the data stored on the disk or the tapes of other machines. Memory hierarchy works because well-written programs tend to access the storage at any particular level more frequently than they access the storage at the next level. That means, first of all, the data will be sent to the first level, then it is going to the next level, next level, next level. Why? And this is also slower. The main reason is that this is going to the next level, that can be slower, then going to the next level, that also is slower, and thus larger and the cheaper per bit. And the overall effect is a large pool of the memory that costs as much as cheap storage near the bottom of the hierarchy, but that serves data to the program at the rate of fastest storage near the top of the hierarchy. That means whatever the data, whatever the hierarchy at the top, that is one of the fastest memory. Why fast? From because that is very close to the CPU. Yes, as a programmer, you need to understand the memory hierarchy because it makes a has a big impact on the performance of your applications. If the data of your program needs are stored on a CPU registers, they are to be accessed in a zero cycle during the execution of the instruction. And if stored in a cache, 1 to 30 cycles. If it's stored in the main memory, 50 to 200 cycles. And if stored in the disk, 10 of the millions of the cycle. Whatever the cycle, whatever the scenario that we are using, that is stored in the millions of the cycle. Then the main idea around the fundamental property of computer program known as a locality, that is trained to access the same set of the data items over and over again, and also uses the data items with a good locality that needs to save the upper level of the memory hierarchy programs where locality and therefore runs the fastest memory. For example, when you talk about the SRAM memory, DRAM memory, ROM memory, rotating, and the solid state disk, that describes how the memory or how they are organized in the hierarchy. In particular, we focus on the cache memory, therefore act as a staging areas between the CPU and the main memory because they know or they have a most important impact on the application program procedures. And we show you how to analyze your C program, that is for the locality, and introduce the techniques for improving the locality in the programs. Now, this is an interesting way to characterize the performance of the memory hierarchy on a particular machine as a memory mountain that shows the read access time as a foundation of the locality. Read access time means whatever the time that is taken to read the data to write the data. Now, first is a RAM, that is random access memory. This is read-write memory. We can read as well as write from the memory. Yes, and there are two types of the RAM: static RAM, dynamic RAM. That is most significant with use with the SRAM and the DRAM. SRAM is used for the cache memory, both on and off the CPU chip, and DRAM is used for the main memory plus the frame buffer of the graphics system. Then static RAM, that is bistable memory cell that is used with the different states, and each cell is implemented with the 6 transistor circuits. Now this is the stable left, unstable, stable right. Then dynamic RAM, this is use or stores each bit as a charge as a capacitor that is very small, typically around 30 femtofards, with that is 30 into 10 power minus 15 farads, that is used with the SRAM, DRAM. And when the capacitor voltage is disturbed, it will never recover, and the exposure to the light rays will cause the capacitor voltage to change. In fact, the sensors in the digital camera and the camcorders are essentially the arrays of the DRAM cells. And whatever the data, whatever the scenario that is taken out with the DRAM cells to lose its charge within a time period, within a bound that cost around 10 to 100 million seconds. And fortunately for the computer operators or operating with the clock cycle, times measured in the nanosecond, this retention time is quite long, and that is also used with the every bit of the memory by reading it out and rewriting it. Now this summarizes the characteristics of the SRAM and the DRAM memory. That is very persistent, we can say constant as long as the power is applied. That means this is volatile in nature. One of the main concepts that is available is volatile and the non-volatile. Whenever we say volatile memory, that means the data will not lost, that will remain constant when the power is applied or the power is supplied. There is no need of the refresh, but and on the other hand, static RAM can be accessed faster than the dynamic RAM. That is not case sensitive, or that is not sensitive to the disturbance such as the light and the electric noise. And the trade-off is that SRAM cells uses more transistors than the DRAM cells, and therefore have a lower densities, more expensive, and consumes more power. And the bits or the cells in a DRAM chip are partitioned into the D supercells, each containing W DRAM cells. DW DRAM that stores a total of DW bits of the information that is used with the supercell that is organized with a rectangular array with the R rows and the C columns. And this has the address of the form ij, where I denotes the row and the j denotes the column. And this figure shows the organization of the 16 by 18 DRAM chip with the D is equals to 16 supercells, W equals to 8 bits per supercell, R equals to 4 cells, C equals to 4 column that denotes a supercell at the address 21. And whatever the information that flows in and out of the chip that is used with the external connectors known as the pin that carries the 1-bit signal. And this is the high level view of the 128-bit 16 into 8 DRAM chip. This is to the CPU, memory controller, address, data. This is the DRAM chip, columns, rows, internal row buffer. And each DRAM chip is connected to the some circuitry that is known as a memory controller that transfer the W bits at a time to and from each DRAM chip. And to read the content of a supercell, the memory controller also sends a row address I to the DRAM that is followed by the address J that is used with the CAS column access stop request. That is a two-dimensional array instead of the linear array to describe or to reduce the number of address pins on the chip. This is the DRAM chip. This is the DRAM chip. This is the reading the contents of a DRAM supercell. Then memory modules that is used with a single inline memory module SIMM that transfer the data in the 32-bit chunks. This is the next problem that is used. Now next is enhanced DRAM. That means enhancing or using more DRAM. So there are many kinds of the DRAM memories. that is used that now appear on the market with the regularity as the manufacturers attempt to keep up with the rapidly growing or increasing processor speed, and each is based on the conventional DRAM cell with optimizations that improve the speed which the basic DRAM cell can be accessed. So one is the fast page mode DRAM, extended data out DRAM, synchronous DRAM, that is the SRAM. Then double data rate synchronous, RAM bus DRAM, video RAM. The non-volatile memory, that content will not be lost. So DRAM and the SRAM are volatile in the sense that they lose their information if the supply's voltage is turned off. And non-volatile memories, on the other hand, retain their information when their power are off. That means the same. Read-only memory ROM are non-volatile in nature and the RAM is volatile in nature. That means data remains constant when the power is on and the data is lost when the power has gone. And RAM is volatile, ROM is non-volatile. And the programmable ROM that can be programmed exactly once, that is also a part of the memory cell which can be blown out by using the high storage, high current. Then EROM, that is erasable programmable memory in which we can erase the data from the memory and the same chip can be reused again and again. And there are two ways how to reduce or how to, we can not reduce, how to erase. One is ultraviolet EROM, that is UV EROM, then electrically erasable EROM. That means in the first part, we are putting the chip in the or under the sun for coming to the ultraviolet rays and erase the data. Then next one is using the electric current for changing or uses the electric current for erasing the data, that is internal also. And this is akin to the EEPROM but does not require a physical separate programming device, that is uses with this one. Then flash memory is also a type of the non-volatile memory that is based on the EEPROM, that is electrically erasable, that becomes an important storage technology that is also known as a solid state disk, that is SSD, that provides a faster, sturdier and the less power hungrier alternative to the conventional rotating disk. And what are the programs that is stored in the ROM chip or the ROM devices are known as the firmware. And when the computer device or system is powered up, it runs firmware stored in a ROM. And some of the system also provides a small set of the primitive input and the output functions in the firmware. For example, PC's BIOS, basic input-output system routine. Complicated devices such as a graphic card, disk drive controller can also rely on the firmware to translate input-output requests from the CPU. Then how to access the main memory that is used with the DRAM. Main memory uses the electric circuits known as the buses. Bus transaction, read transaction that transfer the data from the main memory to the CPU. Write transaction that transfer the data from the CPU to the main memory. And bus is a collection of the parallel wires that carries address, data and control signals. And this is the example bus structure that connects the CPU and the main memory. The CPU places the address A on the memory bus. Main memory reads A from the bus word and place it on the bus, and CPU reads the words X from the bus and copies to the register EAX. Now next is the disk storage that stores enormous data to the thousands of the gigabytes as opposed to the hundreds or the thousands of the megabytes in a RAM based memory. And this is DRAM is more longer than the SRAM. The disk geometry, this is the spindle surface area sectors. Now, as I told you in the last class, there are latency time, seek time. So these are the tracks, and in between these are the sectors. These are the sectors. Now, the latency time is putting onto the sector, and the seek time is putting onto the tracks, and the access time is a combination of both track as well as the sector, that is latency plus seek time. And the disk manufacturer, that capacity is also used within the disk bytes. Then disk operation, that is using the read-write head connected to the end of the actuator arm, that is used with this one, and this mechanical motion is known as a seek. That means seek time. Now this is the same as I told you: seek time, rotation latency, and the transfer time. Seek time, to read the content of some target, we need to first go to the track, that is known as the seek time. then transfer time, then logical desk blocks, that is divided into various parts, that is surface, tracks, this one. Then how to connect with the input output devices, that is also one of the part, this one. Now this